Hey, this is Andrew Brown. Today is August 9th, 2019. I'm the CEO of Exam Pro, and today I'm bringing you a talk called Building Your Own Event Tracking and Analytics Systems on AWS. So in Exam Pro, we're building out our own analytics dashboard called Team Insights. And the idea behind this dashboard is it gives us insights into the activity of our users so that we can create a better educational learning journey for them and try to figure out how to get them certified faster and just understand trends in learning. And we're hoping that with all this raw data, we'll eventually be able to train an instructor bot, which is definitely for a future talk. But today I'm going to show you how we actually implemented our own event tracking analytics systems in Exam Pro. So here are some of the business objectives that we laid out when deciding to build our own event tracking analytics systems. So we want to track various click events in our smart LMS. We want to have total ownership of the data, so we're not going to use a third party like Keen. We want it to be a cost-effective solution, and one of the things that play into that cost-effective solution is how frequent we need those reports, and we can live with reports that are generated once a day or on demand. So when the user actually needs that report, it will generate, and they can wait a little bit of time to get the report. And the last thing is we want these reports to be directly integrated into our web application, because as it's called Team Insights, the idea is that we want to expose this dashboard to our users so that if you're a school or a boot camp or an organization, you can monitor your students or employees to see how well they progress within our system and making sure that they're actually learning if your goal is to make sure that they learn AWS. So here we have a technical architecture. We're going to be coming back to this architecture time and time again, so don't worry about memorizing it here. But the first thing, before we actually jump into implementation, I'm going to talk about Kinesis and the different analytical solutions that we had considered and why we chose the one that we chose. So first, I'm just going to cover the different flavors of Kinesis. So we have data streams, Firehose, analytics, and video streams. Video streams we're not going to worry about because we're not analyzing video at this point in time. It's not important to us. So we have three other likely candidates. The first one at the top, data analytics, sounds like what we want, right? Because we want analytics. But the thing with data analytics is that it's for real-time analytics. And anytime you think of real-time, you think expensive, right? And so data analytics, what it can do is it can take an input from a Kinesis stream, and then an output is a Kinesis stream, and then it can run SQL queries on real streaming data. So that's pretty cool, but again, it may not be the most cost-effective solution for us, and we will explore that in the next slide. The next option is Firehose. So Firehose, I like to say it's dumb, easy, and cost-effective. It's just an ingester, so it just takes data in, and as data leaves a Firehose, it disappears from the Firehose, so there is no retention, and you can specify the consumers that you want. So we have S3, Redshift, Elasticsearch, Splunk, but you can't manually create your own consumers. You're limited to that pool, but that's fine because we only care about S3. That works for us, and it does have some compression options such as encryption or changing the format of the files. And that's something we may want to take advantage of. And the last one is data streams. And data streams, I think Firehose actually is built on top of data streams, but you pay per shard that's running. And so unlike Firehose, you just pay for the data that passes through it. So if you have 50 terabytes that go through Firehose, you're only paying for what's consumed or pass through the actual hose, whereas data streams, you're paying as long as the shards are running, so it's going to be a more expensive solution. However, you get some trade-offs such as persistent data, so if you want to keep things in your stream for 24 hours to, I think, up to a week, I believe that's the range I believe it can do. Data streams can do that. It has more richer integrations. It does ordering of the data for every consumer. It keeps its own position. So if, ordering of the data is very important. That's going to matter to you as well. And the other thing is you have to manually write your own consumers, which is good if you need to work with something other than S3, Redshift, Elasticsearch, or Splunk, such as maybe Dynamo DB or something. However, the downside is you have to write your own consumers. So there you go. But we'll look at some architectural solutions that we did consider and why we decided not to use them. So the first one at the top, first thing we thought is like QuickSight. Why don't we use a business intelligence tool? AWS has one where you just connect a database or sources to QuickSight and then it automatically visualizes it. However, what we found out is that we cannot embed that dashboard into our application. So that was kind of a letdown for us for a user experience, but we still thought, okay, well, maybe it's really cost effective or it's convenient to use, so maybe we might be able to do it. But we found out it's $5 per reader, so it's more like a consumer product where it's like pay per reader because it's designed to use by a business, not like a consumer product. I know I said like consumer product, but I meant to say like if you are a business and you have 100 employees, then you're paying per head, whereas like if we're a platform that's Exam Pro where we could have thousands and thousands of users, then it does not make sense, the pricing model for us. So QuickSight was not the option. One other thing to note is that to get data from Dynamo DB, which is where we're storing our data, into QuickSight, we would have to use Glue, which is not a big deal. But I just want to point out that QuickSight doesn't have, you can't use Dynamo DB as a source. You have to transform your data before you can insert it into QuickSight. And so the next option was this, using Kinesis Analytics. And I like to call it the Kinesis sandwich because Kinesis Analytics always uses input stream and an output stream. And right away, you're seeing 3 Kinesis services, and that gets expensive really fast, especially if you have to use data stream on both ends of the inputs and outputs. Because here you can use Firehose and Firehose or data stream and data stream. But, if we wanted to put our records back into DynamoDB, which is recommended by AWS when you look into their architectures, you'd have to write a custom consumer, and then that could be then sent to DynamoDB. So you'd have to use data streams in here. And so that could get really costly very quickly. And then our last solution, and this is the one we're using, is where you're just using Firehose and Athena, okay? So Firehose, it just passes data along. It only you only pay for the consumption. So here, if we run, if it's you can see the price point is 0.29 terabytes ingested. So you have to consume a lot of data before you're paying any money. So Firehose is really cheap. And so the way we do queries is with Athena. And so Athena is 5 terabytes of data scanned. So example here, 304 queries would result in $1.48. So it's very inexpensive, but only if you can predict the usage and throttle how fresh the data is. Because if we are consuming data real time, Athena gets really, 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 really expensive very fast. And then it would make sense to use Kinesis Analytics. But for our use case, we can predict how often we want to produce reports because we'll know how many people actually have Team Insights. And we can make those reports only as fresh as once or twice a day. And we can even save more money by only generating them on demand. So we can really predict that amount. So Athena is the perfect choice for us. So back at our technical architectural overview, we're going to actually look at the implementation. And the first thing is, how do we get our data into DynamoDB from our Ruby on Rails application? And that's what Exam Pro runs on. And so what I did, or our team did, is we created a module here using the Ruby SDK, so the AWS Ruby SDK, to put data into DynamoDB, okay? And so these are the records that we're doing it. And then we wrote our nice convenience function. And this is watching videos or doing logins. And we also have a JavaScript version of this, so we can do it client side as well. If you were inserting data from from your application, so go back here for a second. If you were to insert data from here into your DynamoDB, the number one concern you'd have with event data or a clickstream is the fact that you'd have a high amount of writes capacity. And so if you're really concerned about price and you don't need super real time, you could put SQS in the middle of that to buffer the writes into DynamoDB. If you've ever taken the Solution Architect Professional, you would see that as a question multiple times over. How do you buffer something like buffer the reads and writes to DynamoDB? You can use SQS. I don't know if I'd ever use it in practicality. I think I could come up with another solution, but just want to point that out there. And so now we have a way to get our data into DynamoDB. So the next thing is the schema and configuration, because a lot of people aren't sure how they should design their database. And there's some configuration things we should bring up when you consider it. So the first thing is the schema. When you're making your DynamoDB schema, you want to have a very unique ID, such as a user ID. There's nothing going to be more unique than a user ID, because there should only be one Andrew Brown in the Exam Pro system. And primary keys are the best fit for them is the distribution across partitions, and so that's why unique IDs are super important. Then we have, as a sort key, dates are very, very good because you want to sort logically between different periods of time. I strongly recommend that you play around with the DynamoDB Table Explorer. So if you're used to using Postgres and you're trying to understand the limitations of what you can and how you can filter it, that's going to really help you determine your unique ID and your sort key. So just play around with this, create a structure, and then delete it and make another one, and then you'll get to this something closer to what you need for production. Here is the actual schema. We're collecting the user ID, the IP address, the user agent, the actual event ID, the event type, and the event at date. One other thing I really want to point out with DynamoDB is that they do not have a date time timestamp data type. Okay, so when you store events in DynamoDB, you have to store it as a string, and so you're going to have to make a decision as to what format you want that string to be, because you can make it anything you want. But there's two that I want to point out that I do recommend. And you can use the ISO 8601 format, which is what we're using here, which is very human readable. That's why we're using it, because we care about human readability. But if we wanted TTL functionality in DynamoDB, that's when an item expires based on a column in your database. So this would be a good way to clean up your database if you want to keep that database small. It has to be an epoch format time for that to work. Okay, so if you really want TTL, put it in that epoch format. If you just want readability when you want to look at it, you can do that as well. So we made the choice, and maybe that will play out well for us, and maybe we'll have to go back and change that. Who knows? So now we're on to the configuration, and so we're talking about write capacity and how we have to be worried about it growing, because it can be, when you're doing, people are clicking. Let's say you have a sale on and now you have a lot of people on your website, we can have a huge spike in write traffic. So we're definitely going to want auto scaling on our write capacity. But you'll notice on my read capacity, I didn't set anything because I don't need to, because I can definitely predict my reads. Because all we're going to be doing with this DynamoDB is, as soon as it gets into our system here, it's going to then output it, or it's going to send it to DynamoDB Streams, to the Kinesis Firehose, and then it's going to put the data there. Okay, so because it's moving the data there, it's really going to be DynamoDB Streams doing the reads. But you're going to think, well, if you have a lot of writes, aren't you going to have the same amount of reads and you'll have to have autoscale on it? Well, no, because DynamoDB Streams won't throttle or exhaust your read capacity. So it's like transactional lock. So I don't have to worry about reads. Okay, so just consider that. And so now we've gotten our data into DynamoDB, and we have it configured in the schema set. Let's talk about actually how do we write our DynamoDB stream to send it to Kinesis. So DynamoDB streams is just a Lambda function. So here we're using the Ruby SDK, and what we're doing with this function is we're getting data in from DynamoDB, and we're going to send it to Firehose here. And the great thing about DynamoDB Stream is that it can accept a batch of records. So if you have a lot of data coming to DynamoDB, it won't just send it won't trigger this Lambda function for every single item that gets inserted in the database. It's going to collect up to whatever amount batch and then send it over. And so we can set that value. We'll see in a later slide here. But I want to point out that when you're writing batch content, and there is a batch functionality to Firehose, you want to really be sure that those records that you're sending to DynamoDB, or sorry, to Firehose, are on an individual line. They're on their own line, because when this goes into Athena, Athena really, really needs the records, the files that it's going to be on individual lines, because it treats every single line like a row in a database, because that's what Athena does. It takes a file and turns it into a temporary database, right? So here we are putting a new line so that we don't have that problem down the road, okay? And so, we said that DynamoDB Streams needs to read from Dynamo, so we give it that access, and then it also needs to write to Firehose, so we do that in our policy, okay? And then to attach our Lambda that we created, we can just go to the stream, attach an existing function. It's a lot easier to do this than making a new one, because you'll have limitations. Right away it'll try to make you use Node. I don't want to use Ruby, so I had to make it ahead of time and attach it. And then what really matters is the view type. If you use new image, old image, new old image, these are a bit confusing, but what I found is that if you, as a programmer, if I have these records, I want to see all of them, right? But if you use old image, it's weird. It will just show some of the records, and then it seems like it does a write or something, and then you see all of your records. So you really just want to use new image. If you use new and old, I believe it would actually trigger two Lambda functions with impartial data and then the full data. So I don't think you'd want that. So I really strongly recommend you're going to want to use a new image for this case. And there's that batch size. So you can set that limit. I don't know what it goes up to. I think by default it's 100. 100 seems good to me. It's something we might tweak in the future. So now we're back to our technical architectural overview. And so we have our Rails app putting the data into DynamoDB. The DynamoDB stream is now sending it to Firehose. And let's talk about the configuration of Firehose. Now I said Firehose is dumb and easy, so I'm not going to show you the whole thing because really you just name it and pick an S3 bucket. But the thing that's I want you to know about it is how it can convert incoming records before you output it to S3. And this is important because since we're using Athena, and look at that, there's a typo. I just found it, cool. But anyway, because we are using Athena, we really want to optimize the reading of those files, and Athena is a bit picky about that. And if you were to convert the incoming JSON files into Parquet files, Athena can read those a lot more efficiently. Also, Athena can, if you compress the files, you'd think it'd be more work, but it's actually less work for Athena. But if you were to compress those incoming files, such as Snappy or Zip or etc., it's less work for Athena to scan those files, and so you're going to get faster queries. You can also encrypt your data, and I recommend you do all these three things. Use Parquet, use encryption, and compress your files. While we were building this out, because we weren't super familiar with this, we just decided to leave it unencrypted and not zip it and use JSON, and the rest of this talk will be with actually using JSON, but I just wanted to point that stuff out for you, and you should consider turning all these three things on. So now what we have is we have our data going into DynamoDB. The data is being streamed to Firehose. Firehose is compressing and like applying transformations on our data. So it's optimized for S3 and putting it into our S3 bucket. And now we're talking about getting Athena to read that event data from that bucket to then create analytics reports, which we're going to put in another bucket that our app will read. Okay. So we're going to look at Athena. And so the number one thing that's annoying with Athena is like, how do I create my database? How do I create my table? Because most of the times you're looking for a button. Where's the create database button? There isn't one. What you have to do is use the query language to create your database and create your table. Now you could create your database and table using AWS Glue. I don't recommend it because AWS Glue using AWS Crawler can look at your files and then determine a schema and create a database for you. However, a lot of times it will create weird partitions or read your actual schema incorrectly. And so you really want to do this manually. If you're just playing around and you just want to get Athena working, definitely can use Glue Crawler. But if you're doing this for production, take the time to learn how to do it the manual way, okay? I do want to point out when you create your table for your table in Athena, you do have to specify your SERDR, your serializer to serializer, so that it knows how to take that file and read each line and interpret it to turn it into a row in the database. So since we are working with JSON data, we are using a SERDR JSON engine here, and there actually are different ones. So this is the one we're using that works for us, and you're going to get different results with different SERDR JSON engines. I think there's only like 2, but this is the one I recommend. If you were using Parquet, you'd have to use a different engine. So just consider that, okay? Now that we have our database and table created, I just want to show you the schema and talk about something that we're dealing with here. So, and we're back to dates. We're always talking about date times. They're always a complication in our pipeline here. And so here you can see that it is a string. Okay, so you might think, well, DynamoDB didn't have a data type for date, time, or timestamp. Maybe Athena doesn't either, but it actually does. It has one called timestamp. But the reason why we had to create it as a string was because Athena cannot read ISO 8601 and turn it into a timestamp. It expects this exact format. So if you want it to automatically read and cast your values into timestamp, it has to be in this format. So now you might go back and think, okay, in DynamoDB, you'll want to use this format, okay, to save you this trouble. But it's not a big deal because Athena has a SQL function that will translate ISO 8601 into a timestamp. So we're not having too much trouble here, but if we did want to be super optimized, we would go back and change that format. And so here's the actual query. So now we have another Lambda function that actually queries Athena. And here you can see the actual query And we actually are using that ISO 8601 to convert that timestamp into a date. So just a few things about writing this Athena, the SDK here was that you'd specify an output. There is a thing called work groups in Athena, which allows you to have named queries. And I would rather not hard code the query into the Lambda function. And so I thought maybe through this the console I could like create those named lambdas and then call that work group named Lambda, but I could not find it in the SDK. So if it is there, I'd love someone to tell me if that's the case, because to me that would be the most logical way. You don't really want to be embedding these things into your Lambda functions, but just wanted to point that out. And so we've come full circle. So our Rails app can put data into our Dynamo DB database, and it sends a stream to Kinesis Firehose, which then goes to our bucket here. And then when a user wants a report, or we could set it on a schedule once a day, it will check the bucket to see if there is a recent file with the actual report. And if it's not, we will trigger that Lambda function, which will then query Athena and then put in our bucket. And then our app will pull that latest one on the next check, or just, in 10 seconds or whenever it finishes. So there you go. That is the way that we implement event tracking analytics system. And yeah, we might outgrow this system and move to real time, but I wanted to show you a practical solution so that you can start using event tracking analytics systems for your applications today. And I just wanted to point out as a bonus slide, if you needed to monitor this, it's not like we can use X-ray. So here I have a CloudWatch dashboard where I'm looking at the insertions into Dynamo DB, and then what gets passed to the streams, and then what gets delivered to Firehose, and then what Firehose reads to S3. So generally, you should see all the same kind of records activity across this. So if there is a problem in your pipeline, you'll find out that way. Great. If there's any questions, leave them in the comments.